Now, what else is happening here is these are no wind conditions. And when freezes happen here in the Northwest, you will note that it is very calm. The nights that it freezes, it will be dead calm. Skies will be crystal clear, and that radiant heat is rising right off of the surface of the earth. In the West, we're pretty fortunate that way. Little different situation on the East Coast, because sometimes they'll get those northern winds coming down from the Arctic. And that air mass that's moving through is cold. So it's blowing cold air through the orchard. You can't heat the world at that point. You know, you'd have to heat a wall of air coming across your orchard continuously. There isn't enough heat out there in the world to do that. You'd be having to run a nuclear plant beside the edge of your field, you know, to put out enough heat to heat all of that air, that Arctic mass, as it comes down across your field. So when you have cold air masses being wind blowing across an area, that's when you have these major disasters. That's when the price of orange juice goes sky high. Because that's what happens in Florida when they have the big freezes. It'll be an Arctic air mass coming down out of Canada that will come across the southern states and freeze out the oranges, the peaches, the whatever is that they're worrying about down there. And boy, the price of fruit goes up that year because they can't warm up the whole East Coast to save it. And so there's years they just have big disasters. There's nothing you can do about that. You know, that doesn't happen on the West. Those Arctic air masses are always on the east side of the Rocky Mountains. They never come down, never say never, but they don't hardly ever come down on the west side of the Rockies, just the way that jet stream takes air around the world. So we're really lucky here in the Northwest we don't get those cold air masses causing a freeze. That's called a freeze, versus this radiant loss is called a frost. And so we don't get the deep freeze concept. We simply have radiant loss nights. Now we love it when the sky stays cloudy, because when there's clouds over the top of us, no radiant heat loss up into the atmosphere. It traps the heat down below the cloud mass, and it doesn't get too cold. Another thing we like is to have more humidity in the air. That will also hold heat. It's when it gets really, really dry that we have the worst and coldest nights for radiant loss. So we really hate to see it get too dry in the early spring around here. We want to keep a lot of moisture in that air if we possibly can. That also helps. As you're irrigating, you're releasing moisture, and then also you're releasing moisture as it evaporates during the day into the atmosphere, and so you're building a little moisture in the air in the springtime when you do irrigate. Now over tree, as we apply that water and we're freezing water everywhere. On the limbs, on the ground, wherever it's hitting. On the sprinkler heads. So we got to be concerned, number one, that our sprinkler doesn't freeze up. So it has to be generally of a material that's not going to freeze up, or the water has to be warm enough that's not going to freeze up the motion on the particular sprinkler. So oftentimes you'll see brass used for frost protection if you're working with impact sprinklers. Plastic impact sprinklers are prone to freeze up because there's no heat transfer in the plastic. There is heat transfer from the water into the brass, so the brass would stay the temperature of the water. Plastic doesn't transfer heat hardly at all. So the plastic ends up being the temperature of whatever the air is around it. And pretty soon it'll freeze up and the water will just be shooting a stream out and it won't be rotating. Another thing is we want pretty rapid rotation. You know, a couple of revolutions a minute is pretty good for minimums on a frost protection system. We want to keep moving across the area with that sprinkler, continuous movement of that sprinkler across the area, so that we're dispersing the water and getting it to freeze as rapidly as we can. So fogging is not bad. You know, a little higher pressure doesn't hurt us a bit in frost protection, because we want to get that water to freeze rapidly. The smaller the droplets, the quicker they'll freeze. So we need to keep the spacings pretty close together if we're going to run pressures where we're going to fog it a little bit. So generally you're looking at that 50% of diameter, which is typical spacing for an orchard sprinkler anyhow. So we can use exactly the same spacings we do to do our standard irrigation. So that doesn't have to change anything there.